This is question number 10 on the sample test problems for test number 3. For each function graphed below, say whether the function could be an exponential growth function, exponential decay function, or neither. If it could be an exponential growth or decay function, give an equation for it. Okay, so what we're supposed to know about exponential growth and decay functions is that growth functions look like this, very close to the x-axis at the far left, and then growing forever to the far right. And exponential decay functions are kind of the mirror image of those, close to the x-axis on the right and growing to infinity on the left. And so one of these guys is excluded from, just doesn't look like either of those pictures, and that's this one here. It doesn't look like exponential growth or decay. It doesn't get close to the x-axis on the left or right. Doesn't grow faster and faster towards infinity on the left or right. So looking at the other two pictures, the first one looks like an exponential decay. And then the last one looks like an exponential growth. So our task now is to find formulas for these two guys. So the basic formula for exponential growth or decay is f of x equals, doesn't much matter what letters you use, I'll say a times b to the x. So that will be our starting formula. And in order to use that formula, we need to find a couple of nice points. So you're looking in the first graph for 2 points that are nice. That is 2 points that are on the graph, but are also right there on the grid. So for example, this point right here is at 0, 2. And this point up here is at -1 and 6. And we'll do the same kind of thing on the graph on the far right. So that looks again like 0, 2. And then one more nice point, maybe this one right here, which looks like 1, 3. Okay, so next fact, make life easier, is to know that A is equal to the value of the y-intercept. So in this first problem, we have f of x equals a times b to the x, but a is the y-intercept, which is 2. So 2 times b to the x. And then over here on the right-hand graph, f of x equals, again, a times b to the x, and the y-intercept here, also 2. So all we need to do now is use the other point to find b. So let's go back to the left-hand graph. And we're going to plug in the point that we're given. -1 is x, and 6 is y. So this is the equation we're after. On the right-hand graph, same kind of thing. 1 is x, and 3 is y. Okay, this equation is easier to solve. We'll stay here. B is equal to 3/2, which means that the final answer for this one is 2 times 3/2. Don't forget the parentheses. They are mandatory, to the x. Solving the other equation for b, we'll go ahead and divide both sides by 2. So we get b to the -1 is 6/2, which is 3. And then what does b to the -1 really mean? It means 1 over b to the +1. So if I multiply both sides by b, I get 3b is 1. And now the b is upstairs, so I can solve for it by dividing by 3. So b is 1/3. And if you're really on the ball, maybe from this equation, 3 equals b to the -1, you can just know right away b is 1/3. This -1 just kind of means flip over the number. So then the final answer for this one, f of x equals, going all the way back up to here. So it's 2 times b to the x, 2 times 1/3 to the x. And just a note, b in this case was 1/3, and the b in this case was 3/2. 1/3 is less than 1, which means there should be exponential decay. 3/2 is greater than 1, which means it should be exponential growth. And if you look at the pictures, the left-hand side is exponential decay, and the right-hand one is exponential growth.